In this video, we're going to start the KutaSoftware free worksheet, Solving Rational Equations Easy. And I'll leave a link in the description below so you know how to get to this worksheet. So our directions are to solve each equation and to remember to check for extraneous solutions. There's 20 problems total on this worksheet, and each problem is kind of tedious, so I'm going to split this up into 4 separate videos, doing 5 problems in each video. So for number 1, we have 3 over m squared equals m minus 4 over 3m squared plus 2 over 3m squared. In order to solve, we need to isolate the variable, which is in this case the m, in order to solve for what that's equal to. What we want to do is simplify first. So we're going to try to find fractions with common denominators and combine them, which we can see we have 3m squared twice. So let's go ahead and combine those numerators. So we'll have 3 over m squared equals m minus 4 plus 2 all over 3m squared. We can rewrite m minus 4 plus 2 as m minus 2. So we can say 3 over m squared equals m minus 2 all over 3m squared. Now I want to get this m, or this m squared, out of the denominator, so I'm just going to multiply both sides by 3m squared. Multiplying the right by 3m squared, we'll remove the 3m squared from the denominator, and then when I multiply the left by 3m squared, the m squareds will cancel out, so I'll be left with 3 times 3, which is 9, and that's going to be equal to m minus 2. And I'll explain that one more time. Since I multiplied by 3m squared over 3m squared is 1, so we'll have 1 times m minus 2, which is simply m minus 2. And then on the left-hand side, 3m squared times 3 over m squared, the m squared over m squared becomes 1. Since any value or quantity divided by itself is 1, so then we have 1 times 3, which equals 9. Now, in order to isolate the m, all we have to do is add 2 to both sides. When we do that, we'll get that 11 is equal to m. So 11 is our answer for number 1. Let's move on to number 2. In number 2, again, we're going to combine numerators where the denominators are the same. So we'll still have 1 over n on the left-hand side, but on the right-hand side we can say 1 minus n minus 1 all over 5n. So that's 1 over n, which is equal to 1 minus n plus 1. Since when you're subtracting the quantity n minus 1, you're subtracting the n and then adding the 1. So that will leave us with a negative n plus 2 all over 5n. And if you need to think of it as distributing this negative. So now that we have 1 over n equal to negative n plus 2 all over 5n, we're going to multiply both sides by 5n. When we do that, the 5n over 5n becomes 1, so we're going to be left with negative n plus 2 on the right-hand side, and on the left-hand side, n over n is 1, so then we have 5 times 1, which is 5. Now we're going to subtract 2 from both sides to get that 3 is equivalent to negative n. Now we're just going to multiply by negative 1 on both sides to get a positive n, so that'll be negative 3 equal to a positive n. So negative 3 is the solution for number 2. In number 3, we have 1 over 3x squared equals x plus 3 over 2x squared minus 1 over 6x squared. Notice that none of the denominators are the same, but we're able to multiply 1 to any quantity and not change it. So let's multiply x plus 3 over 2x squared by 3 over 3. 3 over 3 is the same as 1, But watch what it's going to do to this fraction. We're going to have 1 over 3x squared, and that's going to be equivalent to now distributing this 3 in the numerator. It'll be 3x plus 9 all over 3 times 2x squared is 6x squared. And then we're subtracting 1 over 6x squared. Now we'll be able to combine the numerators since the denominators are the same. So we have 1 over 3x squared equal to 3x plus 9 minus 1, which will be plus 8 all over 6x squared. Now I'm going to get this 6x squared out of the denominator, so I'm going to multiply both sides by 6x squared. Doing this on the right hand side, I'll be left with just 3x plus 8. On the left hand side, however, the x squareds will cancel out, and I'll be left with 6 times 1 over 3. So that'll be 6 over 3, which we know is equal to a positive 2. So we have 2 equivalent to 3x plus 8. Subtract 8 from both sides to get that negative 6 on the left is equal to 3x. Divide both sides by 3 to get that negative 2 is equal to x. And that's the solution for number 3. Let's move on to number 4. Now remember, there's multiple ways to solve for a variable. For example, we can start by multiplying this 5 over n by n over n to get n squared in the denominator so that we can combine the fractions. However, instead of doing that, I'm just going to rearrange this equation since I already have an n squared. So either way to start is acceptable. It's just a matter of preference for you. So I'm going to go ahead and show you by rearranging the equation first, but feel free to multiply by n over n to that 5 over n and then solve from there. So in order to rearrange this equation and get the n squareds on the same side of the equation, I'm going to add 1 over n squared to both sides. When I do that, subtracting 1 over n squared and adding 1 over n squared will cancel out on the right hand side, and on the left I'll have 4 over n squared plus 1 over n squared, and that's going to be equal to 5 over n, since that's what's left on the right hand side. Now that I have a common denominator, I'll go ahead and add. 4 plus 1 is equal to 5. So I'm going to have 5 over n squared equal to 5 over n. Now I want the n out of the denominator. If I multiply both sides by n, unfortunately, since this is an n squared, I'll still have an n on the denominator even after I multiply by n. So instead, I'm going to multiply both sides by n squared. Doing that will leave me with 5 on the left-hand side equal to 5n on the right. Since you can think about this as 5 over n times n times n, so one of the n's will cancel out, since n times n is equivalent to n squared. So we have 5 equals 5n. I'll rewrite that up here, so 5 is equivalent to 5n, and when you divide both sides by 5, you'll get that 1 is equal to n. So the answer for number 4 is 1. Now on to number 5, and this is the last problem we're going to do in this video. So before we go over the answer to this, please remember to like this video and subscribe to my channel. All likes and subscriptions are greatly appreciated. So let's go ahead and get on with number 5. Again, I'm going to start by rearranging the equation. Since I already have 4n squared twice, they're just not on the same side to where I can combine them. So I'm going to add n minus 3 over 4n squared to both sides. Doing so will leave me with n minus 3 over 4n squared plus 3n plus 15 over 4n squared, and that's going to be equal to 1 over n squared. Now I can combine the numerator, and I'm going to combine the like terms. So I'm going to combine the n's together, and then I'm going to combine the numbers together. So n plus 3n is going to be 4n. Negative 3 plus 15 is going to be positive 12. So I have 4n plus 12 all over 4n squared, and that's equal to 1 over n squared. Now I'm going to multiply both sides by 4n squared so that my 4n squareds will cancel out. So I'll be left with 4n plus 12 on the left-hand side, and my n squareds will cancel out on the right. So I'll be left with 1 times 4, which is 4 on the right-hand side. Subtract 12 from both sides to get that 4n is equal to a negative 8. Then divide by 4 to get that n is equal to a negative 2. So the answer for number 5 is negative 2. Please join me in the next video for this worksheet where I'll do numbers 6 through 10. In this video, we're continuing on with our solving rational equations free KutaSoftware worksheet. And remember, there's multiple ways to reach each solution. So if you got your solution a different way, that's perfectly fine as long as you get the same answer. And I'll try to mix up the ways that I reach a solution so that you get an understanding of how to go about solving. So with number 6, we have 1 over 2n squared plus 5 over 2m equals n squared. As you can see, there are no common denominators, so I'm going to create one. Remember that you can multiply any quantity by 1 and it will still have the same value. So I'm going to multiply the 5 over 2n by n over n, which is equal to 1. Multiplying by n over n will leave me with 1 over 2n squared plus 5n over 2n squared, since n times n is n squared, and that's going to be equal to n minus 2 over n squared. Now that we have a common denominator, we can combine the numerators. So 1 plus 5n is going to be 5n plus 1 all over 2n squared, and that's equal to n minus 2 over n squared. Now I'm going to multiply both sides by 2n squared to get that out of the denominator. When I do this, on the left-hand side, I'll be left with 5n plus 1, and on the right-hand side, the n squareds will cancel out, so I'll be left with 2 times n minus 2. What I need to do next is distribute that 2. So the 2 gets multiplied by the n, and it gets multiplied to the negative 2. So rewriting this, I'll have 5n plus 1, and that's equal to 2 times n, which is 2n, and then 2 times 2 is 4, and we're subtracting that 4, so I'm just going to add a negative 4. And remember, we're isolating the n, so we're going to try to get that by itself. We're going to do that by subtracting 2n from both sides to get that 3n plus 1 equals a negative 4, and then I'm going to subtract 1 from both sides to get that 3n equals a negative 5. Then all we have to do is divide by 3 to get that n is equal to negative 5 thirds. Negative 5 thirds is the solution for number 6. And number 7, we have x minus 6 over x equals x plus 4 over x plus 1. I'm going to start by rewriting this 1. I'm going to rewrite it as x over x, since x over x is equivalent to 1. Now I have a common denominator on the right, so I can combine the numerators. I'll have x minus 6 over x on the left, and that's equal to x plus 4 plus x all over x. So x plus 4 plus x is 2x plus 4 over x. Now I'm going to multiply both sides by x to get it out of the denominator. When I do that, since x is also the denominator on the other side, we'll be left with only the numerators. So we'll have x minus 6 equal to 2x plus 4. Now I'm going to subtract x from both sides to get that negative 6 equals x plus 4. And then I'm going to subtract 4 from both sides to get that negative 10 is equal to x. And that's my solution for number 7. Now in the beginning I started by rewriting this 1 as x over x, but if you notice we already have a common denominator, so you could also start by rearranging the equation. If you started by rearranging the equation, you could say x minus 6 all over x minus x plus 4 all over x equals 1. Doing that, you'd be able to combine right away. So then when you combine the numerators, you'd get x minus x, which is 0, and then negative x minus 4, which is negative 10. So you would get negative 10 over x equal to 1. Then you would multiply both sides by x to get that out of the denominator. So you would get that negative 10 equals 1 times x, which is x. So you can see that even if you rearrange the equation at the start, you will still get the same solution. Either way to go about problem 7 is correct. In number 8, I'm going to start by rearranging the equation. I'm going to move this 1 over 2n to the other side. So I'm going to subtract a 1 over 2n from both sides. Doing that, I'll have 1 over 4n squared on the left, and that's going to be equal to 1 over 4n minus 1 over 2n. I still don't have a common denominator, but I can create one by multiplying this 1 over 2n by 2 over 2. 2 over 2 is the same as multiplying by 1, but when I do that, I'll get 1 over 4n squared equal to 1 over 4n minus 2 over 4n, since 2 times 1 is 2, and 2 times 2n is 4n. Now that I have a common denominator, I can simplify the right-hand side. So I'll have 1 over 4n squared, and that's equal to 1 minus 2, which is negative 1 over 4n. Now I'm going to go ahead and multiply both sides by 4n. Doing that, I'll have negative 1 on the right-hand side, but on the left-hand side, I get rid of the 4 in the denominator, and I only get rid of one of the n's. So I'll still be left with 1 over n on the left-hand side. If you need to write it out, think of it this way. 4n times 1 over 4n squared is the same as 4n times 1 over 4n times n. Then you can see that the 4n's will cancel out, leaving you with 1 over n. So feel free to write it out if you're still not completely comfortable with exponents. So now we have 1 over n equal to negative 1, so we still have to get this n out of the denominator, and we'll do that by multiplying by n. We'll have 1 on the left-hand side, and that's equal to negative n on the right. We need this n to be positive, so we're going to multiply by negative 1 on both sides to get that negative 1 is equal to n. And that's the answer in number 8. In number 9, I'm going to start by rearranging the equation, and I'm going to subtract 1 over b from both sides. Doing that, I'll be left with 6b plus 18 all over b squared, and that's going to be equivalent to 3 over b minus 1 over b. 3 over b minus 1 over b simplifies to 2 over b, and we'll have 6b plus 18 all over b squared still on the left. I'm going to multiply both sides by b squared, and doing so, I'll be left with 6b plus 18 on the left-hand side, and the b in the denominator on the right gets canceled out, but I'm still left with 1b in the numerator. So then that'll leave me with 2 times b, which is 2b. Now I'm going to combine like terms and solve. So I'm going to subtract 6b from both sides to get that 18 is equal to negative 4b. Since 2b minus 6b is negative 4b, divide both sides by negative 4 to isolate that b, and I'll get that negative 18 over 4 equals b. But wait, we can simplify this down since they're both even numbers. So dividing both by 2 will give us negative 9 over 2. So b is equal to negative 9 halves for number 9. And lastly, in this video, we'll do number 10. Remember, in the next video, we'll do the next 5, and then in the fourth video, we'll do the final 5 problems. In this problem, I'm going to start by creating a common denominator on the left. I'm going to do that by multiplying by 1, which in this case 1 will be x over x. Doing this, I'll have x over 2x squared minus x minus 1 over 2x squared equal to 3 over x. Now I can combine the numerator. X minus 1, I'll have x minus x, which is 0, and then minus a negative 1, so I'll be left with a positive 1 in the numerator. So it'll be 1 over 2x squared equals 3 over x. Now I'll multiply both sides by 2x squared. I'll be left with 1 on the left-hand side, and that's going to be equal to 3 times 2 times x on the right, since the x in the denominator cancels out with one of the x's in the x squared. So I'll have 6x on the right-hand side, and when I divide both sides by that 6, I'll get that 1/6 is equal to x. So 1/6 is the solution for number 10. And as always, feel free to like this video and subscribe to my channel. And if you have any questions, please feel free to comment below. You can ask about a specific number that we've done in this video or any of the previous videos, or you could also propose a new question or a new problem that I haven't done yet. And I also take worksheet requests. So go ahead and leave those in the comments below. This is video 3 of the Solving Rational Equations Easy Worksheet on the KutaSoftware website. In this video, we're doing numbers 11 through 15. And remember, there's multiple ways to reach each solution, so feel free to do it a different way. In number 11, I'm going to start by rearranging the equation. I have two denominators that are the same, but I need them on the same side in order to combine. So I'm going to start by subtracting 1 over b squared minus 7b plus 10. I'll have 1 over b minus 2 on the left-hand side, and that will be equal to 2 minus 1 over b squared minus 7b plus 10, since I can combine the numerators on the right. So 2 minus 1 over b squared minus 7b plus 10. So I'll have 1 over b minus 2 on the left, and then 2 minus 1 all over b squared minus 7b plus 10 is the same as 1, since 2 minus 1 is 1 over b squared minus 7b plus 10. However, instead of writing b squared minus 7b plus 10, I'm going to split it up and write it as b minus 2 times b minus 5. Now you may be a little confused at how I can change b squared minus 7b plus 10 into b minus 2 times b minus 5. But think about foiling this. So first, outside, inside, and then last. That's how you're going to multiply each of the terms. B times b is b squared. Negative 2 times b is negative 2b, but you're going to add that to negative 5 times b to get that negative 7b. And then negative 2 times negative 5 is a positive 10. So we have b squared plus negative 7b, or minus 7b, plus 10. An easier way to think about that is that the 2 and the 5 have to add to equal 7 and multiply to equal 10. So negative 2 plus negative 5 equals 7, and negative 2 times negative 5 equals a positive 10. So now that I've rewritten that, I can multiply both sides by b minus 2 over b minus 5. When I do that, the b minus 2 times b minus 5 on the right-hand side cancels out, and the b minus 2 on the left-hand side cancels out. B minus 5 times 1 is b minus 5. Then all I have to do is add 5 to both sides. That will leave me with b equal to 6. And that's the solution in number 11. Let's move on to number 12. In number 12, again, I'm going to rearrange so that we can combine similar fractions. So I'm going to start by subtracting 1 over x squared minus 3x from both sides. Doing that will leave me with 1 over x minus 3 on the left-hand side, and that's equal to 3 minus 1 all over x squared minus 3x. We have 1 over x minus 3 on the left, and that's equal to 3 minus 1, which is 2, all over x squared minus 3x. We can simplify that by pulling an x out. So we'll have x times x minus 3. Since x times x is x squared and x times negative 3 is negative 3x. So x times x minus 3 is equivalent to x squared minus 3x. Now, we'll be able to multiply both sides by x times x minus 3. Doing that will leave us with the positive 2 on the right-hand side, and the x minus 3's will cancel out, so we'll be left with x times 1, which is x. So x equals 2 is the solution for number 12. In number 13, we're going to have to make a common denominator. Remember, multiplying any quantity by 1 will not change the value. So if I multiply 1 over p minus 5 by p over p, which is that 1, since p over p is equal to 1, I'll have 6 over p, and that's equal to p all over p times p minus 5. Then we're going to subtract p plus 4 all over p squared minus 5p. And notice that now we have a common denominator, because if we were to distribute this p, we would get p squared minus 5p. So we can combine these numerators now. We'll have 6 over p, so p minus p plus 4 is p minus p, and then we're subtracting that 4 since this negative, or the subtraction, would be distributed. So we'll have negative 4 all over p times p minus 5. And that's because, if you need to write this down, that p squared minus 5p is equal to p times p minus 5. They are equivalent. But you can see that now all I have to do is multiply by p times p minus 5 to cancel that out on the left-hand side. And when I do the same to the right, p times p minus 5, I cancel out the p in the denominator on the left. So I'll have 6 times p minus 5, and that's equal to negative 4. My next step will be to distribute that 6. So 6 times p is 6p, minus 6 times 5 is 30, and that's equal to negative 4. Adding 30 to both sides will give me that 6p is equal to positive 26. Then I'll divide both sides by 6 to get that p is equal to 26 over 6. But we can simplify this down. If we divide both by 2, so 26 divided by 2 is 13, and 6 divided by 2 is 3. So p equals 13 thirds is the solution for number 13. In number 14, again, I'm going to start by rearranging this equation. I'm going to subtract a 5x minus 20 all over x squared minus 9x plus 18 from both sides. So when I subtract it from this side, it'll cancel out with this positive, and then I'll subtract it from the right. I'll be left with 1 over x minus 6 on the left-hand side, and that's equal to x minus 4 minus 5x minus 20 all over x squared minus 9x plus 18. So x minus 4 minus 5x minus 20. So 1 over x minus 6, and then I'm going to distribute that negative. So x minus 5x is going to be negative 4x, and negative 4 minus the negative 20 is going to be negative 4 plus 20, which will be a positive 16. So negative 4x plus 16 all over x squared minus 9x plus 18. But let's look at this x squared minus 9x plus 18. I want to rewrite that as x plus or minus some quantity times x plus or minus some quantity. So we need to see what two numbers add to give us a negative 9 and multiply to give us an 18. So let's think about the factors of 18. We have 2 and 9, but there's no combination that would create a negative 9 out of that. We also have a 3 and 6, which if we take negative 3 and add it to negative 6, we'll get that negative 9, and a negative 3 times a negative 6 is a positive 18. So the numbers we're looking for are x minus 6 and x minus 3. That would give us x squared minus 9x plus 18. So I'm going to rewrite x squared minus 9x plus 18 as x minus 6 times x minus 3. So rewriting that in the denominator, x minus 6 times x minus 3. Now I'm going to multiply both sides by x minus 6 times x minus 3. You'll see that on the right-hand side, that denominator will be canceled out. So I'll have negative 4x plus 16, and that's going to be equal to, on the left-hand side, x minus 6 cancels out. And we have 1 times x minus 3, which is x minus 3. Now I'm going to combine like terms. I'm going to add a 3 to both sides to get that x equals negative 4x plus 19, and then I'm going to add a 4x to both sides to get that 5x equals 19. Dividing both sides by 5, we'll isolate that x, and I'll have x equal to 19 fifths. So 19 fifths is the solution for number 14. Moving on to number 15, I'm going to start this one by multiplying 6 over 5k plus 2 by a 1. And that 1 is going to be k over k. Doing this, I'll have 1 over 5k squared plus 2k minus 6k over 5k squared plus 2k, and that's equal to 6 over 5k squared plus 2k. So combining these fractions, I'll have 1 minus 6k all over 5k squared plus 2k, and that's going to be equal to 6 over 5k squared plus 2k. I'm going to multiply both sides by 5k squared plus 2k, which is the same as multiplying by 5k plus 2 times k. So 5k squared plus 2k. On both sides, the denominator will be canceled out, and we'll have 1 minus 6k equal 6. Subtract 1 from both sides to get that negative 6k equals a positive 5. Then we'll divide both sides by that negative 6 to get that k equals 5 over negative 6, so negative 5/6. So negative 5/6 is the answer for number 15. And that wraps up the third video. Please join me in the next video where I'll do numbers 16 through 20, finishing out the worksheet. Also, please remember that all likes and subscriptions are greatly appreciated, so go ahead and do that now. In this video, we're going to finish the Solving Rational Equations free worksheet on the KutaSoftware website. I'll leave a link in the description below so you know how to access Solving Rational Equations easy. So feel free to subscribe to my channel and like this video before we get started. In number 16, we're going to start by multiplying by a 1. The 1 that we're going to multiply by is n minus 2 over n minus 2. So think about this. What two numbers add to give us negative 6, but multiply to give us a positive 8. That's going to be negative 4 and negative 2. So n minus 4 times n minus 2 is equal to n squared minus 6n plus 8. So we'll have 6 over n squared minus 6n plus 8, and that's going to be equal to 1 minus n minus 2, since 1 times n minus 2 is n minus 2, all over n squared minus 6n plus 8. So we have 6 over n squared minus 6n plus 8, and that's equal to 1 minus n. Distributing that negative would be plus 2. So we'll have negative n plus 3. And that's all over n squared minus 6n plus 8. Multiply by n squared minus 6n plus 8 on both sides. And the denominators will both cancel out with the quantity we just multiplied by. So we'll have 6 equal to negative n plus 3. So subtract 3 from both sides to get 6 minus 3 is positive 3, and that's equal to negative n. So all we have to do is multiply by a negative 1 to get that negative 3 is equal to a positive n in number 16. In number 17, let's start by combining the fractions on the right. We'll have 4 over a, and that will be equal to 1 minus a plus 3. So it'll be negative a plus 1 minus 3, which will be a negative 2. So negative a plus negative 2. And that's all over the same denominator, a squared plus 4a. So we'll have 4 over a equal to negative a plus negative 2 all over, and we're going to rewrite this denominator. We can pull out an a to get a times a plus 4. And you can see that if we were to redistribute that a times a is a squared, and a times 4 is 4a. So we did the reverse of the distribution to pull out that a, and now we're going to multiply both sides by a times a plus 4. When we do that, the a's will cancel out, so we'll be left with 4 times a plus 4. And on the right, a times a plus 4 will both cancel out, so we'll be left with negative a plus negative 2. I'm going to start by distributing that 4. So I'll get 4a plus 16 is equal to negative a plus a negative 2. I'm going to add a to both sides to get 5a plus 16 equals negative 2, and then I'm going to subtract 16 from both sides to get that 5a equals negative 18. Then my final step is to divide both sides by 5. That will leave me with a equal to negative 18 fifths. And that's the solution for number 17, negative 18 fifths. In number 18, I'm going to go ahead and combine the 3 with the k minus 6 since they have the same denominator. 3 minus k minus 6 is the same as 3 minus k plus 6. So we'll have a negative k plus 9. And that's all over k squared plus 5k plus 6. And that's equal to 1 over k plus 3. Now again, we're going to think, what two numbers add to give us 5 and multiply to give us 6? Well, they're both going to be positive, since we have a positive 5 and a positive 6, and the factors of 6 are 1 and 6 and 2 and 3. And indeed, 2 and 3 add to give us 5. So we're going to multiply both sides by k plus 2 times k plus 3. when we do that, since k squared plus 5k plus 6 is equivalent to k plus 2 times k plus 3, those will cancel each other out, and the k plus 3 on the right-hand side will cancel out. So we'll be left with negative k plus 9 equals 1 times k plus 2, which is k plus 2. Adding k to both sides will give us 9 equal to 2k plus 2, so then I'll subtract 2 to get that 7 equals 2k, and then all we have to do is divide by 2, and we'll get that 7 halves is equal to k. So 7 halves is the solution for number 18. And number 19, we're going to multiply 1 over v plus 3 by a v over v. So we're multiplying by 1. That v times v plus 3 will equal this v squared plus 3v. So we'll have v minus 3 over v squared plus 3v, and that's going to be equal to 1v, so v minus v minus 5 all over v squared plus 3v. Since the denominators are now the same, we were able to combine those numerators. So we'll have v minus 3 over v squared plus 3v, and that's equal to v minus v, which is 0, minus a negative 5, which would be a positive 5. So 5 all over v squared plus 3v. Now we're going to multiply both sides by that v squared plus 3v to cancel out the denominators on each. That will leave us with v minus 3 equivalent to 5. We'll just add 3 to both sides to get that v is equal to a positive 8. And that's the answer for number 19. And feel free to write out this step. I know I condensed it a little bit by multiplying 1 times v and then v times v plus 3 in my head, but feel free to write this out and then show the subtraction. And lastly, on to number 20. We can start by combining the numerators on the right-hand side. We'll have 1 on the left-hand side, and that's equal to 3 plus 3m all over m plus 3, since those denominators were the same. Multiply both sides by m plus 3 to get that m out of the denominator. When we do that, we'll have m plus 3 equal to 3 plus 3m. I'm going to start by subtracting an m from both sides to get that 3 equals 3 plus 2m, and then I'm going to subtract a 3 from both sides to get that 0 equals 2m. The next step will be to divide by 2, and 0 divided by any number is 0, so m is equal to 0 for number 20. And with that final answer, we wrap up the Solving Rational Equations easy worksheet on the KutaSoftware website. Go ahead and leave a comment below if you have any questions at all. Also, like I said in the very beginning, don't forget to like this video and subscribe to my channel.